Alright, in this video we want to talk about combining some of the stuff that we've already talked about: scientific notation, engineering notation, units. And we're going to use what are known as prefixes. These prefixes are going to enable us to be able to combine our notations and make quick calculations in our head. So prefixes, first of all, if you have something that's 10 to the 0 in your scientific notation, there simply is no prefix. And there'll be no symbol. So for instance, if you had 3.2 times 10 to the 0 meters, this has no prefix, so it's simply written as 3.2 meters. Now you probably never do that. You just say, oh, well, that's just meters. Well, that's true. That's why. It doesn't have a purpose. If it's 10 to the third, the prefix is kilo. Small k. It's interesting enough that this is the only thing that has a number with a positive set of exponents, that is a big thing, that has a little letter for the prefix. That's because the big K was already taken by Lord Kelvin, and K had to be capitalized because it was a name. So it wouldn't have made sense if we had KK, kilo kelvins, and they both had the same thing looking at them. So we have little k instead of big. So its symbol, little k. 10 to the 6th is mega, and it's a capital M. 10 to the 9th is giga. That's a capital G. 10 to the 12th is tera. So if that's a billion, that's a quadrillion. That's tera, capital T. So we talk about TeV, a quadrillion electron volts, when we're talking about the gigantic atom smasher, for instance, that just found the Higgs boson, we believe. On the other hand, we often deal with small things. 10 to the minus 3, that's a milli, and that's a little m. 10 to the minus 6, that's a micro. Now we have a problem here. We've already used big M and we use little m. So we use the Greek m, which is mu. So we used a small Greek m. Nano. You hear about nanotechnology. That means we're talking about 10 to the 9 meters. That's on the order of an atom. Okay, a few atoms. 10 to the minus 12, that's the pico. I like to joke that that's the Pokemon unit. Little p. Notice all of the little letters. 10 to the minus 15. 10 to the minus 15 is a femto. That's a little f. 10 to the minus 18 is atto. There's one for that too, but it turns out that at least in introductory physics courses, we rarely get to that. We do deal with femto meters. We'll deal with, for instance, femtofarads, picofarads, nanofarads, microfarads. A lot of electronics deals with this region here. We also deal with kiloohms, mega ohms. So electronics definitely deals with a lot of different sizes. Now here's how we're going to use these units. We're going to use them to eliminate that times 10 stuff that we had before. So the first thing, I've got a bunch of stuff here, and I want to show you maybe some of the advantages of this by asking the following thing. I want you to think, okay? I want you to think about these set of objects that are listed in your notes, and I want you to come up with a physical object that has that mass or that size. So for instance, tell me something that's 123 meters in length. Tell me something that's 0.0000457 meters in length. Tell me something that has a mass of 0.0000762 kilograms. I want you to give me something that has that. Now, then we're going to change these into new units and see if you don't find that it's easier to find quantities that have these values once we convert them to something that looks more familiar. But stop your video now and work through and write me particular things that you think have this size, this length, or this mass. So hopefully you've come up with some things that you think fit these particular values of measurements. And let's use engineering notation and rewrite these things. 123,000 meters, that would be 123 times 10 to the third meters. Well, 10 to the third meters is a kilo, so that would be 123 kilometers. Well, a kilometer is just a little bit less than a mile. So is the object that you thought about something that was about, roughly, say, 100 miles long? Well, 100 miles, that's just kind of like the distance from Stephenville to Dallas. So that would be a reasonable thing. So did you come up with that this should have been like the distance from Stephenville to Dallas, or some other corresponding, something on the order, roughly 100 miles? It sure better not have been the height of a building. It couldn't have been the length of a football stadium. You see, this number is so hard to get a feel for in its present form, but much easier when I'm looking at something where the kilometer immediately gives me a reference. It's about a mile. And then I'm just dealing with the number 123. I'm not dealing with 123,000 something. Likewise here, 1, 2, 3, 4, 5, 6. So about 45.7 times 10 to the minus 6 meters. So that's on the order of about 45.7 microns. Now, a micron is on the order of a scratch. In fact, a submicron finish means that because you can't see scratches, it's smaller than the wavelength of light. The wavelength of light is about half a micron. I know this much physics. So this tells me that this is about 90 times the wavelength of green light. That's small, okay? It's much smaller than a millimeter. It's on the order of human hair, something on that way. So, you should have come up with something on the order of, say, size of hair. Maybe a scratch. It sure shouldn't have been something like a worm. It can't be the size of an atom. It's not the size of anything on an airplane wing. Again, very hard to get a feel for this. I have a much better feel when I take advantage of the engineering notation and then eliminate it by using these microns so that I have a feel for what that. And now I'm just dealing with the number 45.7. That's about 50. 2 times that's about 100. 3 times that's about 150. I can make rough calculations quickly. When you're working with people in the industry or whatever, you're going to need to be able to make calculations. When you're dealing with drugs and you're putting them in a patient, you need to be able to immediately check to know whether the amount you're giving them is potentially dangerous or not. You won't make bad mistakes if you have rough thumbs. That is, you can quickly compute about how much something is. If there's something wrong, you're going to pick it up. You can't see it in this type of version. You can see it when it's written like this. One more along the same line. Let's take this number here. Let's see, it's 3 and 6. So this is 76.2 times 10 to the minus 6 kilograms. Now, kilograms, the reason I did this one, it's kind of weird. All right, so make sure I did that right. Yes. A kilogram, remember, is 10 to the third. So this is 76.2 times 10 to the minus 6 times 10 to the third grams. Well, 10 to the minus 6 over 10 to the third, that's 1,000 divided by 1,000 times 1,000. That's 10 to the minus 3. In other words, minus 6 plus 3 gets minus 3 up there. So this should have been 76.2 milligrams. Milligrams are like medicine. So, small amount of medicine would be an example of that. Give you a rough idea, a gram is about the weight of a raisin, okay, about the mass of a raisin, and this thing is only about 76 1,000th of the mass of a raisin. So a raisin would be way too large. Did you come up with something that had that size? Learn to use units and be good at units. They're an essential thing for a professional who wants to be able to solve technical problems. So use these results and go back and check to see if what you did previously was reasonable. We always want to be able to check our work.